And here's another gravitation question. So this one is asking us to calculate the gravitational field strength of Earth at its surface. And we know it should come out to be 9.8 meters per second squared. So above, I'll just write it out again. So we have force of gravity is equal to mass times gravity. So remember there's two equations we have. And the other one is that GMM over R squared. So what we need to recognize is that this is the true equation for gravitation, GMM over R squared. However, because on Earth we so often use the acceleration due to gravity at 9.8, that's why we remember that number. But it's always, that comes from the capital G multiplied by the mass of the planet divided by the radius of the planet. So what we can see is because we have two equations for force of gravity, if we equate them together, we can see the masses are going to cancel out. So if we want to find the acceleration due to gravity at any distance from a particular body, we can see that G is just equal to the gravitational constant of the universe multiplied by the mass of the planet in this case, and divided by the distance, or radius squared. So we plug in our values. 6.67 multiplied by 10 to the negative 11 newtons meter squared per kilogram squared. Mass of Earth, once again, 5.97 multiplied by 10 to the 24 kilograms. And our radius of Earth, 6.38 multiplied by 10 to the 6 meters, and we square it. Plugged all in, and we end up with 9.8 meters per second squared.